What's going on, beautiful people? I hope you guys are having a fantastic evening. I'm sorry for such a late video, but you know I got to get the content in after making some serious money for the day. I want to talk a little bit about ChatGPT for enterprise that is coming out and Palantir Aip. And I want to put this question, is Palantir dead? Is ChatGPT putting the nail on the coffin when it comes to Palantir Aip? And is this a Palantir killer? The answer is no, no, and no. Let me explain it in the easiest possible sense. ChatGPT for enterprise is fantastic, but it's more so a tool, a helper. Think about an Excel sheet. Think about an Asana. Think about programs like that make you more productive. Think about a 24-hour help center, customer service. Think about something like that. I believe ChatGPT 4 is going to be a fantastic tool for a lot of businesses, from small size to mid-size to large-scale businesses. I think it's going to be absolutely phenomenal, and it's going to solve a lot of questions and make workers and businesses more productive. It's going to be faster, twice as fast as ChatGPT 4 is right now. You're going to have unlimited amounts of prompts that you could do. Right now, if you're paying for ChatGPT 4, you could do 25 in a 3-hour period. And you're going to have more a breakdown of code. And you're going to be able to tie in your APIs as needed, which is fantastic. ChatGPT 4 for enterprise is ridiculously good. However, it is extremely limited and extremely lean. It is not a transformative program. It is not an enterprise builder. It is not an empire maker. It's not. It doesn't revolutionize your business. It doesn't take your business to the next level. It makes your business better by making productivity go up for your employees, okay? That's ChatGPT 4, and I love ChatGPT because I use it every single day. I use 5 different AI applications and websites every single day. Palantir artificial intelligence platform is real artificial intelligence and real machine learning packed together and stacked on top of Palantir Foundry and using ontology, aka digital twins. Palantir Aip stacked with Palantir Foundry and the digital twins is an enterprise builder, an empire maker, straight up revolutionary for your business. Faster, stronger, more capabilities, more secure, so on and so forth. Comparing ChatGPT for enterprise and comparing Palantir Aip is just not fair. That's like saying you have a person that's digging for something with their hands. All of a sudden, you give them a shovel and a pick, and they are so much more efficient. Well, that's ChatGPT 4. They take your game a step up, make you better. But Palantir Aip would be an entire excavator. You understand what I mean? And not only an excavator, but an excavator that comes with an entire construction team. It is not the same thing. And I'm not shitting on ChatGPT because I think it's amazing and I would definitely get it for my business. There's so many businesses that don't have enough money to pay for what Palantir offers because their offerings are super robust and expensive. And people need to understand that. It is not a direct competition. Sure, there are some overlapping things, but ChatGPT is just a helper, a virtual assistant, so to speak. But Palantir actually allows you to transform your business and help you make decisions. I have Palantir Aip demo. I'm going to play it for you right now. It's a 1-hour-long demo. Please, as a matter of fact, you got to be an absolute schmuck if you don't watch the next 1 hour. I only got around 2,000 views on this video where I have a breakout demo of Palantir artificial intelligence platform. And if you look at this and you actually mess with ChatGPT, you guys are going to understand what I'm saying. And if you guys don't watch this demo video that's going to be 1 hour long, something's wrong with you if you're invested in Palantir. It shocks me. It's mind-boggling that people are invested in a company, invested in a stock, and you don't do your own research, and you don't do your due diligence, and you don't put as much time as possible to ensure that you know as much as possible about the underlying investment that you are doing. I'm not trying to shit on you, but do more research so that you know your investment is solid. Unfortunately, a lot of people don't do that. A lot of people don't even know that Peter Thiel is one of the co-founders of Palantir. Needless to say, people have no idea that Palantir is literally the Don Dada of the so-called PayPal mafia. But this is neither here or there. No, my friends, Palantir is not dead. It's just getting started. And ChatGPT 4 for Enterprise is the most beautiful complement that you can possibly do for Palantir AIP. And yes, Palantir AIP is that revolutionary item building an entire market around it. A small niche market that's expanding, so on and so forth, making essentially a monopoly. Palantir AIP was here over 5 years ago. This is just the first time that it's popular and people are learning about it. But we had this technology over 5 years ago. Guys, enjoyed this demo, and please, I urge you, watch the demo. And if you guys want to support the channel and buy me a cup of coffee, channel membership $3 a month. I just started a brand new series about a wheel strategy for options where I update it every single week with an Excel sheet and a spreadsheet where I show people how to make a synthetic dividend, aka selling cash secured puts, and if assigned, selling covered calls, and if assigned, going back to cash secured puts. If this sounds foreign to you, just become channel members. You guys are not going to regret it, and you will get your $3 worth. There's going to be a link down below. Please enjoy the rest of this demo. Please actually watch the demo so you understand what you're actually investing into. Thank you, and have a great evening.
You know, one thing that's really exciting for us is that what we're showing sort of reflects the pace of product development itself, in that, you know, the demo sort of changes on the hour. So would be my great pleasure to introduce Akshay Krishnaswamy here, our chief architect, who's at the forefront of these product development efforts and the deployment of AIP with customers. So we're going to spend a little bit of time kind of introducing the platform, telling you kind of what's under the hood. And then we're going to spend the majority of the time showing you the software itself in the same way that we have these discussions with customers. You'll see a box on the right where you are very welcome to drop questions. You know, if we see a critical mass, actually, I might interject in the middle and make this a little interactive. But please feel free to drop questions of any sort, and we'll get to as many as possible. Akshay, over to you.
Thanks so much, Sasha. And thanks everybody for joining today. As Sasha said, my name's Akshay. I've been at Palantir for a bit over 10 years. I'm our chief architect, and super excited to just walk folks through.
That's a big shot right there. He's a big shot.
AIP conceptually, but also show you the product and walk through kind of a very live demonstration. As Sasha said, things are changing essentially every week. So if you tune in next time, you might see something new. And I think I'm looking forward to the questions as well. Just so we'll try to leave time at the end for that for sure. So probably 35, 40 minutes of content, and then jump into the Q&A. But just to orient folks a bit on AIP and kind of where we're at Palantir, you can think about AIP, our newest platform, our AI platform, as essentially having as its mission statement, enabling enterprises to securely harness LLMs within their core operations. And I think that core operations piece, if you're familiar with Palantir at all, is kind of a through line through all the work we've done historically across the different product lines and work that we've done really over the past few decades. And just to kind of paint it in perspective, if we think about how most folks are familiar with LLMs today, to take like a cheeky example of, let's say, a chat-based interface, I think we've all seen examples of this, probably used it ourselves, right? Just to orient ourselves, where we think about, for instance, something simple, like interacting with an LLM or some sort of advanced AI to ask a question about where I should go for dinner tonight, let's say for a restaurant on a romantic meal on a budget, right? And what I can then sort of rely on is that the model that's receiving that request can redirect me maybe to some of its own information, or can sort of parlay things into a set of services it has plugins for, and then it can get me some options back. And it's all, pretty seamless because it's actually not super complex. The model's sophisticated, but the whole interaction scheme is pretty simple, right? There's no friction between me and the model. It's all public data it's accessing. And if it gets something wrong, it's not the end of the world, right? I can go and do something myself manually, and there's very low risk to this decision or this sort of return from the model being, incorrect or, below par. Just to kind of stick with this frame, again, we talked about operations in the last slide. If we think about just sort of a cheeky upscaling of this idea to enterprise operations in supply chains, in retail, in manufacturing, in logistics, it looks a lot more complicated to ask the kind of questions that they tend to ask, right? I might ask the question, for instance, just reading this from left to right, what are my alternatives to fulfill orders to our customers before the hurricane hits our distribution centers? That's a pretty intricate question, right? If I ask that to an LLM, first I want that thing to be running in a governed way, within my own network or within security policies that I stipulate. And then to even begin to answer that question involves having to interact with tons of different enterprise data, right? That's often unstructured or semi-structured and exists in many different places. And, even in the platonic case where the model has access to all of this data, do I want it to have access to all of the data? I probably want it to only have surgical access under certain conditions, depending on who's asking the question, what the circumstances are, and every other consideration under the sun, right, that pertains to my enterprise. And so there's this first mile, which is huge around just being able to assemble the requisite data picture for the model to be able to interact with a human and answer the first mile of this question. But then I don't want to stop with just simple retrieval, right? I want to actually have some sort of solution or proposal from the model that's probably augmented by my enterprise context, right? So we think about these as action pathways or decision flows that could happen. I need to, for that to even be in the realm of possibility, the model has to understand what my notion of a distribution center is, what actions I typically take under different circumstances, and be able to show options that actually make sense in my world. And that all has to then, on the far right-hand side, actually culminate in some sort of interface that can allow for kind of human-computer interaction and iteration together. And at the bottom, I think they're at the bottom, but they're really important points, which is this doesn't even take into account complex regulations and audit requirements, if I'm going to use this for highly regulated or, of course, enterprise settings, the friction between the LLMs and the data that changes over time we talked about, and the tolerances or the consequences of being able to understand when I would even do this, depending on my enterprise workflow. And so the point is this gets a lot more complicated at enterprise scale versus that super simple chat example we saw before. And being able to use LLMs and the latest generation of AI in operations, we think, involves fundamentally contending with and addressing this complexity. And so I won't bore you by reading all the tiny text on this slide, but I wanted to at least show an overview of what AIP is, and it's very rapidly, sort of evolving. It consists of many components, from how do you get secure access to different LLMs, both third-party and commercial LLMs? What is the pipeline building story for building the semantic and kinetic context in which to operate? What is the ontology that can be used by both LLMs and humans to be able to work together in shared operational settings? And then there's a whole bunch of other considerations, from vector stores to tool-based plugin paradigms, orchestration, scenarios, automation, validation. There's a lot. And I won't be able to show all of it to you today, but I'll show you glimmers of kind of these kind of keystone capabilities you see called out here. And one thing that we'll come back to, I think that a lot of this revolves around, is that shared context layer between humans and AI. For those of you that are familiar with Palantir, you've heard us say the word ontology a lot. And we really do think this is a generational moment for folks who build ontology systems and are willing to integrate their operations into an ontological form. Because if you think about what we're talking about, or what we've historically talked about, but I think is now really progressing in a new wave of development, there are three kind of requirements we think of when trying to get everything into an operational state for humans and AI, right? The first is you need a full fidelity digital representation of the organization that's accessible to both users and AI. You need to then define the actions and processes upon which both people and AI can operate. And then you need a full spectrum control plane, which you can use to control, govern, and monitor deployment of AI across all contexts. So put another way, that is a shared data layer where you're actually integrating all the different data sources together into a semantic representation that can be used by both human and agentified users. It's a shared action layer. And again, don't worry about the tiny text here. We'll come to it in the demo. And then it's also a shared strategy layer. And those three things being together allows you to then, we think, actually fit the bill for being able to do some of those workflows like what we saw conceptually a few slides ago. So I'll show you one more slide, then we'll just jump into the demonstration itself, which is a theme you'll see throughout the demo is this notion of having a shared toolkit between humans and AI. And what you'll see is that toolkit is built out of both out-of-the-box applications that Palantir provides as part of AIP and its sibling platforms, and also tools you can build as development teams as you want to basically make AIP your own in your enterprise and make sure it's fitting your custom workflows. So let's just jump into it. And I think if any Palantir person, by the way, spends longer than like 5 or 6 minutes in PowerPoint, you should probably just leave the call. It's not worth it. So here we are in just a kind of like bird's eye view of how we might conceptualize of an ontology that we're going to use and refer to as we show all the different applications in AIP coming to life, right? So in this case, I'm going to take on the role of a notional manufacturer. So you're going to see the nouns of my world are things like, supply chain, customers, trucks, shipments, distribution centers, and things like that. But keep in mind that this could be very different depending on the use case. So, if I'm working, at one of our medical partners, for instance, you're going to see very different sort of icons or sort of use cases that are pertaining to hospital beds or hospital networks or things like that. Let me just refresh here. There we go. So ambulances, nurse schedules, beds, that might be the set of objects in that world. If I'm working in a different environment like finance, I'm going to think about banks. I'm going to think about customers, fraud patterns, transactions, and those are my nouns in my world, or the objects that might make up my ontology. And then, of course, in oil and gas, I won't belabor the point, but there's a whole different set of things you care about. And so what we'll show is that to build this world is in and of itself an exercise that AI can help with. So there's, of course, a data integration task, which involves bringing together all of the data kind of continuously from different sources into this semantic representation. So how do I think about structured data systems, unstructured sources, business critical transactional systems, IoT sources, third-party systems, everything that I want to be able to represent in this ontology. And I think this is a pretty big distinction from the prior world of data architectures, where you're being quite often parsimonious about what data you want to represent because of efficiency reasons. With AI, the context in the pipelines is instrumental. And so actually being able to pull in more and more contextual data that might have been semi-relevant in the past, but is very relevant for AI, I think changes the game when it comes to data integration, kind of in this new frontier we're in. So there's data integration, but then there's also model integration too. And I want to be kind of clear about what I mean by models coming into the ontology or the central place, which is models are all those models that we've been building already, using data science teams, using folks who are building forecasts, building optimizers. Like, these will be tools for LLMs and other more advanced AI to use. So it's a combination of data and models, again, that will be shared by humans and AI. And then what we'll see is how this comes to life in analytical tools, in application building, and then can serve as the foundation for third-party application building too. So, okay, it's great if I can do all this inside of the confines of AIP, but how can I make use of that in my own third-party platforms too? So let's jump into it and start with, this notional manufacturing example. It's going to be this company called Titan. And if we're a user that's kind of used to interacting with our ontology, there's maybe many applications I could manually jump into myself and start to just work with, independent of even having AIP, right? So there is, like, let's say a supply chain control tower, there's an investigation workbench, there's all sorts of ways I can search through all the data that we have. But I'm just going to start by, jumping into maybe one of these applications that's been custom built for me, which is our control tower. And here, what we're going to see is essentially everything we have displayed kind of across the world, right? So it's going to show us kind of everything that is sort of here, sort of globally for our plant operations. And I'm going to choose to, for instance, maybe zoom into something happening in Boston, right? So I'm going to just search for that, and it's going to take me right to the plant that I care about. right? And so I'm going to open this particular plant and start to ask questions of it. And I could start to do my workflows like I normally could, kind of with the existing tool set that I might be familiar with from other Palantir tools. So I can see things like real-time data. I can see things like, real-time emissions coming in, uptime. I can see downtime causes of people that have linked in other analyses for me to consume, kind of the whole collaboration model I might be historically sort of familiar with here. But where it gets interesting is being able to use AIP to start to answer these questions more proactively and using machine assistance instead of me having to come and necessarily do everything manually myself. So let's say, and I have an example here, that I have an alert that's come in that talks about some sort of disruption to a distribution center, right? And normally I could use all the kind of tools and investigation methods here to manually resolve this, but I want to just jump in and start to, make use of this myself with AIP, right? So I'm going to jump over to an application here that's called AIP Terminal, and I'm going to start by asking questions of the data so I can start to get answers without having to do all of those operations manually myself. So I saw that there was something wrong with one of our distribution centers, and I want to know what customer orders would be affected if there was, in fact, I think it was a weather event that's incoming to the Vellner Medical Distributor, right? So I'm going to say, show me all of the customer orders that are linked. In this case, I'll just close some of these here. All right. That are linked to the Vellner Medical Distributor, right? So I'm just going to ask this kind of first query here of the data that we have. And what you'll see in this sidebar here, if I switch to our handoff view, is AIP is actually going to take my query and it's going to say, well, how do I convert that question into a series of operations that can use the tools that are available to me as the AI helper? So in this case, it's actually done a series of operations I could have done manually, right? So here you'll see that it has taken, the original prompt that I gave it, and it's actually mapped that to a set of secure plugin operations using that plugin framework we talked about to be able to filter down and then show me the linked customer orders using the Link Explorer tool. So I can sort of see how its chain of thought is functioning, which allows me to sort of trust that it's operating in the same way that a team member or I might if I was doing a similar inquiry, right? And so this is like a first pretty simple query, but I might say, okay, that's interesting. I want to now kind of go a bit further, right? So show me, I see that there's current status here. So show me the current, status of these orders on a bar graph, for instance, right? And so I want to start to visualize what's going on here and maybe see a bit more information about it. And so this is going to use a different set of plugins that AIP has access to, right? So before we were doing some object link navigation, but now what we're going to ask for is essentially a visualization that allows us to, understand more about these sets of customers. And so this is going to pull back not just a static visualization, as we'll see, but a pre-built application state that I can interact with. And so here we see, deliveries are completed, the deliveries are waiting for shipment, kind of everything in between. I'm just going to select those that I care about, which are the deliveries that are waiting for shipment, because I know that will be those that are critically impacted if we had this weather event hit in this notional example we're in, right? So you can see I can sort of interact with the output here, and I'm going to down select further to just the deliveries that are waiting for shipment. And now I'm going to ask a question that, for those of you that have been playing with LLMs, know is a bit perilous to ask to an LLM normally, which is calculate something for me, right? What is the total value of these orders? Is something I might ask, right? And so this is going to then, as you'll see, invoke a different tool. And we don't want the LLM itself to do mathematics, right? Because under the hood, the LLM, for those of you that have burrowed into the transformer sort of literature and understand how it's working, it's essentially just trying to predict the next token. And so it's going to give me some answers that might seem believable, but probably aren't. And so here I can see that it's using the data aggregation tool, and it's handing off the calculation to a part of the platform that does calculus, right? And it's saying, here is the result. And so we can go forward with that with confidence, right? And so I can kind of continue to do operations here and kind of interact with all of the things that AIP has the scope to act around and within. So I can always say, okay, what does AIP have access to see? Here are the actions it can take, and here are the object types that are in its scope. And so for any application or any profile or any user that you set up with AIP, you can set these guardrails. So you can say, what can they interact with sort of not just independently, but globally, and set these sort of Venn diagram permission structures in place to ensure you always understand why the AI is able to retrieve certain things. We're gonna kind of just take this one level further, which is, it's great that I'm been able to do some kind of ad hoc visualizations here, but I do want to actually go to an application that I use regularly to kind of just triage the output of my workflow, which is our customer order management application. So I'm going to say, can you open the customer order management application? And so this is actually kind of a handy search function where, especially as I'm working in the Palantir tool sets across Foundry and Gotham, there's a lot of applications that have been built. Can you surface what's relevant for me and allow me to, leverage the work that somebody else has done and kind of build on it? And so what this will do is say, okay, yeah, I did find that application for you. And I might have found some other applications that are nearby too. And here we can see kind of like what I can actually do about, customer order management in the context of this particular scenario. And it's going to kind of load in all of the state with the full application context here for me to be able to work with, right? So it's going to generate actually a live view of our network and show us kind of everything that's interconnected here as well. And so I could, of course, interact with this here. But one thing that I might notice is, we need to be able to respond to these disruptions in a way that actually takes into account the emails and the inbound signal from our distribution center teams. And while it's great that I got one email from one person ad hoc, there's actually an entire email pipeline we haven't set up at all to be able to make use of all the signal that will help us better optimize these customer orders. So to give you an example of what I mean by that, I'm just going to jump over to kind of the under the cover view of what is going on with the object model that AIP was interacting with, right? So we were talking about, in that case, the different distribution centers, which we have here, which were linked to deliveries and manufacturing plants and so on. And kind of what this spiderweb view is showing is what my data engineering team might have seen when they were creating kind of the foundation for AIP to interact with in that ontology. And if I zoom kind of all the way out, what this is essentially showing me is like what is contributing to that ontology right now. So we can see kind of all of the open data sources. We can see the Oracle systems, SAP systems, NetSuite systems, the real-time systems too. But if we kind of pan over, we'll see, okay, there's an entire kind of email data set that we have that's not being factored in at all. And that's probably getting us valuable signal about how we want to, actually prioritize our triage operations. So how can I get this data set into AIP so I can then do more with AIP? And I think we'll then kind of switch personas to show that here. So I'm going to switch over to now just a slightly different view of how, we started by showing how a user could kind of get to this point if they're asking business questions and want to use LLMs. But how about somebody who needs to build that data pipeline to connect our emails in? What do they do? And so if we jump over now to a data pipelining view, we can take a look at how AIP can help us here as well. So this is a different application, which is called Pipeline Builder, where we actually have the raw data sets that we saw before, right? So we have our emails that are parsed, we have a material table, we have our staff members data set, and now there's somebody, kind of productively yelling at me saying, we need to integrate this data into the ontology so I can use it in my workflow. And so normally I'd have to kind of sit there and say, okay, I need to, Pipeline Builder is a very handy tool set. I can come in here and start to do joins. I can come in here and start to do kind of all the operations that I might expect from a pipeline building process using no code. And it's pretty fast. But can I just ask AIP to be able to start, build a starting pipeline for me if I just express my wants in natural language? And so what I'll do is actually select these data sets and I'll do exactly that. So I'm going to define here
this is
what I actually
fucking
want the
nuts.
pipeline to be that I would normally create manually myself. So I'm going to say, okay, so we're starting with, this emails data set. I want to remove any duplicate emails. I then want to add info about materials only if the material is mentioned in the email. It's kind of a specific clause, right? And then I want to say add the to and from staff member, add the to and from staff member information. So that's from the third data set now, right? And then add a column called email type, which is set to disruption. So I want to know if it's a disruption or not. If the email mentions disruption, delay, or issue. So like this is kind of like me making a wish normally, right? To anybody to be like, hey, can you come? Or like maybe a work order to one of my developers to say, can you come in and actually do this for me? And I'm just kind of articulating the instructions here to AIP. And so I am going to then click generate here. And this is going to go through the series of operations where it'll first do the mapping of, okay, like we took the prompt, we have on the back end, sort of the set of different operations that Pipeline Builder has about what it could consider when wanting to build the pipeline. And then as we'll see, it can then progress to constructing the pipeline itself. And this will take about 60 to 90 seconds. And as it constructs this, I want to show you another sibling feature here in the Pipeline Builder application, which is as this constructs, you might say, well, okay, that's great if I'm starting from scratch. What about for pipelines that I've been building for years or that I already have in my organization? And so this is a different pipeline that's already constructed that consists actually of, I see like a Santander, cycle bike points data set, some UK postal codes. I have no idea what's going on with this data set, right? And somebody might have created it years ago, and I want to be able to document it, but they had no documentation for the data set either. So I can always just select any pipeline in AIP, and I can say, use natural language to explain what's going on here. And so in this case, I'm coming at it from the other end of I inherited some work, and I want to understand what's going on. And it says, oh, so this is combining data from different sources to create a data set of bike stations in London, including their location and borough and every sort of other piece of information there. And it does this by joining the data, and it kind of gives me the whole explanation of what's going on here. And I can then affix these explanations as new enrichments on the data itself. So this is something that I might have inherited, but if we go back to our other data set, we'll see it's done. And we can say, okay, what did it do? It parsed and joined the email, material, and staff member data sets to create an output data set with information on emails mentioning specific materials sent from and to specific staff members and categorized by email type based on content. Pretty good. Sounds good. Let's take a look at actually what it's doing though, right? And we can say at every step along the way, it actually documented its work, right? So it's better than me at writing pipelines, right? It's actually documenting what it's doing every step of the way. And so if I actually go and inspect what's going on, let's say in this first join, right, where it says it was joining the distribution center email data with the material data, and I kind of open this up, you'll see that it did an admirable job of trying to sort of reason about my instructions, which is it did this thing where it was looking for the material name in the body of the email and then saying, cool, we did that and we joined based off of that. The problem is if I look at the material column that it's choosing here, you'll see that it chose material, which makes sense, but that column only has numbers in it. So you're never going to find syringe or thermometer or things that make sense using that column. So I'm going to come in and tweak AIP's output here to be material description instead, right? And so I can make these surgical changes. And kind of one of the core tenets of the tool set is I, as the human, can always come and kind of modify what the AI has done, right? And I can kind of train it if that's an option with a particular model, or at least with our sort of prompt engineering, and ensure that we can capture the feedback on when it sort of did the thing I wanted, and if not, how I can edit it going forward. So I'll apply this now, and because of the power of Pipeline Builder, this will update right here live. I don't have to wait for the whole pipeline to rerun, and I can come back to the graph and kind of continue onwards. I'll check one final step too, because there's one other kind of tricky piece here where I asked it to pull out keywords and then make a disruption column based off of that. And we'll say, okay, wow, it did like a pretty complicated case statement here where it was looking at the body of the email and actually saying if these words were found, it's going to actually generate me disruptions or kind of whatever other kind of alert based word I wanted. So this saved me a lot of time. I'm glad that we used AIP to build this email kind of output here. The final step of connecting it to our ontology is just to be able to say, I want to create a pipeline output. So what I can do here is say, I'm going to create a new object type. And this new object type is going to, let's say, be, we're going to call it our Titan distribution center email. It's going to autofill kind of all the properties I want. And I can, of course, come in here and customize this more. So I want to have a different icon and maybe the color should be different too. And I can set up kind of my ontology sync here. Simple as that. Whereas before it would have maybe required me writing a ton of code using SQL or Python to get to this point. So that's awesome. So let's say the emails are now linked in. Now the question is, how do I use that new data source in other ways I want to leverage AIP? So when I build applications and when I want to set up more sophisticated logic to be able to kind of go beyond just kind of simple atomic workflows like we've seen so far. So I'm going to switch back to where we were before, where when we saw this view and we said, I really wish there were emails here. Well, now I can add in the emails. So what's really great about how AIP is leveraging applications that already exist in your ecosystem is I can click this edit button, for instance, and just jump right into the editing interface for this application if I was somebody technical or on the application development team that had access to do so, right? So here it's going to open up this particular application and show me the editing view that I can now use to make modifications. And in this case, add information about those emails that we saw before. So this is going to kind of load everything in. And then we can see a couple of things here, right? One is I can see, some of the other folks that might be working on this application. Hi, Wes, how's it going? I can also see the different things that this application has access to, right? So I can say this current application state, I have allowed to have access to our customer objects, our customer orders, our distribution centers, and our distribution center emails. And what's really cool is while this in the past might have just been the scope that I have access to, it also can be the scope now that our AI assistant has access to as well. And so you'll see this AI assistant down at the bottom. And what I'm going to do is actually generate a new view here that we can use to bring in that newly integrated data. So what I'd really like is some sort of overview or some sort of like flyover that kind of shows the information, right? That kind of like zooms out like that. Yeah. And so like, how do I engineer kind of like this with the data that I want? And so I can just come in here and start to make some modifications. So I'm going to open this up and say, for this section here, I'm going to call this our emails. And I could come in here and add kind of any widget that I want, right, as an application builder. But it would be great if I could get some assistance, again, from AIP, which could be hitting many different LLMs. And we actually could have tuned to use different LLMs based on different operations that we want to use. So I don't have to know that complexity here, but I might say, okay, can we create a table of emails? Just sort of like generically kind of asking that question to the assistant here. And it's going to reason about and see if it can do that, right? It's going to say, okay, I'm going to identify the widgets at my disposal. I'm going to configure the dependency parameters, and then I'm going to configure a table of emails. So in this case, cool. That brought in the emails that we integrated from before. And I can now say, okay, how do I want to kind of further refine this? So I might say, well, there's a lot of information here that I really don't need for further use. I don't need to pollute kind of this view with all these other things. So I'm going to say, update this table to only show, in this case, I'm going to say email type. And what else do we want? Subject. And so I could have done that manually myself, right? But it kind of shows that the full expanse of operations is accessible to AIP to be able to reason about what's there as well. So in this case, it just shortened that to email type and subject. And we'll kind of reload the table here. I continue onwards, kind of just working with this application state as I want to, right? And the point is that AIP as sort of an assistant, again, has bounded access, bounded scope, and I can use it in application building. I can use it in pipeline building. I can use it for exploration. And I think the final thing we want to show you is, well, how can I use it to really go beyond traditional workflows? So in this case, I might have set up what's essentially an alert end for those emails that are coming in. But I want to move into solutioning. So can AIP help me, turn this into a solution inbox that can be, kind of more proactive and more suggestive of proposals of how to fix these issues versus just flagging that they exist. So that's where we're going to go kind of as the last mile here. And to do that, I'm going to switch over to a final application called AIP Logic to show you how that kind of comes to life. So in this case, let me jump in here, and I'll kind of do a little bit of stage setting here just because we've been flying around a lot, I know. So I want to kind of show where this all fits in. So just to kind of quickly orient us again before we go into AIP Logic, let's jump back to this slide and just recap a bit of what we saw before we go into the final mile. We saw how we can use different applications. So 10, Terminal is the chat-based application that you saw to interact with AIP and all of the sophistication in it. Terminal, by the way, and other applications like Workshop, which is the application building interface, can interact with kind of all of the data in the ontology. And the ontology, of course, is enriched by the pipeline building application that we saw. And what you've seen throughout is how the ontology with different AIP applications is also pulling in from the plugin service, is also pulling in from other models that we have, and of course, interacting with all the LLMs themselves. So you've kind of seen a dance across this surface area in the demo so far. And kind of what's in the center here is where we're going to go to next, which is AIP logic. And this is, I think, a very exciting piece because it really shows how you could think about moving to production with workflows that are inherently somewhat statistical, right? So the magic and kind of the double-edged sword of LLMs is, you know, they're a breakthrough in language model and kind of like linguistic reasoning when it comes to, you know, sort of being able to involve statistical approaches and convex optimization in normal business processes. But that also means you have to be kind of careful that they don't hallucinate or don't make up actions or pursue actions without being anchored to reality. And so logic is kind of one of the first product efforts that we have around how do we square that circle and get the confidence we need to actually use LLMs in more sophisticated multi-step workflows. So if we jump in now, what I'm going to do is open up a sort of logic file here and start to reason through a starting workflow live that we build together. So the first thing is I kind of want to take the emails that we integrated before, and I want to be able to start to parse out the information that's in there to suggest how I can think about recommended solutions to all these disruptions that are happening across our distribution centers. So how do we get from A to Z? Well, let's start by saying that I want, you know, our email objects, right? So I'm going to tell logic what I'm talking about here is our distribution center emails, right? And so these are going to be our email objects. And I'm going to start simple. I'm going to say all we're trying to do is to get certain properties extracted from those emails that we're then going to feed to the LLM and do more sophisticated activity with. So let's start by saying, okay, for the emails, I want to pull out certain properties of that email data set and make it accessible to the AI, right? So I'm going to pull out the DCID. I'm going to pull out the from email. I'm going to pull out the to email. I'm going to pull out the body, and I'm going to pull out the subject as well. So this is just a subset of fields that I'm then going to call the email content, right? And so this is just a very simple operation of just saying extract data from the data set. Nothing super complicated here happening, but I'm going to open up the debugger, which is what allows me to interactively kind of test my logic as I'm progressing step by step. So I'm going to actually find just a simple email to use, a sample email, which is our syringes shortage that we saw earlier that we integrated in. And I'm going to run just this first prompt and see what happens. So, okay, it spits out essentially this whole output here around, here's all the information from the email that you wanted, the body, the to email, the subject, etc. Okay, great. But now I want to use the power of LLMs to do interesting stuff. So I'm going to say, let's add a first LLM block. And you'll see that's a block alongside creating variables, creating object properties, or doing other operations.
I am going to buy myself some happiness.
Take a set of tools and outputs and the chosen structured object, right? So here I'm going to actually give it a system prompt that's going to start to resemble human instructions, right? So I'm going to say, find other emails that describe similar events to those. Oh, let me change that here. Similar events to those described in the input email at any location. So even though this pertains to Columbus, I want it to be any of our locations that are mentioned in these emails coming in about potential disruptions, and look only at the email body. And so that's the first instruction. But I actually want to give it a second instruction too, which is, given that, determine the best solution based on what has worked in the past. Make one solution recommendation. So we're giving it very specific instructions here. And what we're going to do is say, okay, the task prompt will be the email content that we developed before. We'll say the output here is our recommended solution. We'll say this is a string as well. We'll set this to be our output. And we could try to just sort of run this as it is, right, and see what happens, where I've described all these things to the LLM, and then I can say run. But what you'll notice is it'll get stuck. And you'll say, okay, like, why is it getting stuck? Like, we gave it some pretty precise instructions. It's just sort of spitting the input as the output here. Well, it's because we didn't give it access to any tools. And so as part of defining logic flows in AIP, again, those guardrails and those security kind of stipulations are so important. And so here I can say, well, I'm going to give it access to one tool here, which is access to the query objects tool. And I'm going to say it's going to have access to query exactly one object, which is other distribution center emails, right? So we're going to say, here are the Titan distribution center emails. It's going to be able to query, and I can then update that kind of modified set of instructions and then run this again and see if it can do what I want, which is, okay, find other emails that describe similar events to those described in the input email, look only at the email body, then determine the best solution based on what has worked in the past. Make one solution recommendation, right? So this is a pretty intricate set of reasoning we're giving it. So now let's run this.
I'm going to buy myself almond's hair
here in this central column, how it's actually functioning. And we'll say, okay, look, it found several other existing emails that we integrated into our ontology that it has matched against now. And it's going to proceed onwards from that. And then it generates an output for us here, right? So at every step of the way, let's just start from the top. We can see the system message that we passed it. We can see the full input. We can see what the assistant thinks it has to do now, which is, kind of fun to read. I need to find similar emails describing events like a shortage and see what solutions were recommended in the past. And it's itemizing what I gave it as instructions. Search for emails with a body containing the word shortage. Analyze the solutions provided in those emails. Determine the best solution based on past recommendations. And then based on that, it gave us an output. So the output here, and we can see it up here in the top right, is based on similar events in the past, the best solution for the syringe shortage at the Columbus Distribution Center would be to reallocate
turn down the mic.
inventory
Is this
from one
better?
distribution center to fulfill the orders. This has been effective in resolving shortages in the past. Sounds pretty good. So that is the first step of reasoning that AIP has sort of given us here, given again that we're giving it very precise instructions and binding it to the ontology through these tools. Now I want to get more intricate here. Where logic starts to get really powerful is not just with single LLM instruction calls, but actually being able to chain these together. And so I now want to add a second LLM block. So let's keep kind of following along here. And I now want to say, okay, well, that was interesting. I now want to add on, based on that output, get the customer orders. Oh my goodness, I got to log in again. Classic. All right, well, as I log in, this is a great time for me to talk about security. So security, of course, applies in a granular level to both humans and AI, and I am no exception to that. And so here we will refresh this and jump right back in. And if I had just set my token expiry to be a little bit longer, that wouldn't have happened, but that's okay. Because you can see this is actually really live. So we're going to go and we're going to select syringes again. We're going to see how far we got. And we're going to rerun this and see if we get the same output. So if we're all good, then we'll continue to proceed here. But I think it essentially just refreshed my login. Cool. So we're getting the same responses. And come on, AIP, you're going to give me the same response that you got before. I think so. Cool. I got the same recommendation as well. So now let's move on to the next LLM block. Okay, cool. So here I'm going to say, okay, based off of your recommendation that you gave me, I now want you to get the customer orders linked to the distribution center that you've mentioned here and filter to the orders for the finished good described in the email. So now you're noticing that we're making kind of lateral movements here, right? It's not just, hey, extract from a bunch of emails what you think, or summarize what the best course of action is. It's like, now get the linked customer orders. Now filter to those orders with finished goods that are described in the email. So it's an intricate set of chained operations that, again, really depend on that ontology being in shape. And so I'm going to give it a more intricate set of object queries this time to be able to fulfill its mandate, right? Before we do that, I'm just going to fill in kind of just the additional prompts here. So we want to give it the email content. We want to give it also the recommended solution. We're going to call the output here supply chain details, and we'll set that to our output. And we're going to give it access to, in this case, 3 different objects, right? The first will be our Titan customer orders. So these will be objects that we want to give it access to, of course. Given the prompt that we gave it, we also want to give it access to our distribution centers. And then we also want to give it access, finally, to our finished goods. So here are our finished goods. So in this case, we're giving it access to 3 tools, and we want it to be able to kind of proceed onwards with this next part of the workflow. So we'll save this, and then we'll run this and see how our intrepid assistant proceeds. So here again, we're going from the top. So we're starting with that, example syringe shortage in Columbus, and it's doing the thing where it first summarizes the course of action based off of all of the other emails it's found. So it's doing kind of this meta reasoning about all the different emails. It's found, kind of a course of action here around being able to switch distribution centers, as we talked about before. And now it's proceeding on to the next step, which is saying, okay, I now need to find the customer orders linked to the Columbus distribution center and filter them to the orders for syringes. And it then itemizes, again, the instructions I gave it. Identify the finished good related to the syringes, get the customer orders linked to the Columbus distribution center. It even gives me the ID, DC16, so I know what it's talking about. And then filter the orders to those for the syringes finished good, right? And so here we actually see it's identified the finished good, which is syringes, or the individual syringe in this case. And it's now showing me every single customer order from that Columbus distribution center that's linked to that syringe. So it's gotten me where we want to go, right? And this is a pretty intricate set of operations that would have been pretty hard to do manually, especially if you think about the first step being, summarize and give me kind of the takeaway of all these emails about the right distribution center reallocation strategy or whatever the remediation plan would have been. And so, okay, we're really getting somewhere now. And I think we want to just kind of take one final step here to convert this again from just sort of querying objects into being able to really commit action. And so I'm going to give us one final LLM block to be able to chain in here. And we're going to give it one more set of instructions, which is we're going to say, check the recommended action and use the appropriate action tool for this recommendation with the following information. And because logic, again, allows me to access all of those prior prompts in a nice kind of, synaptic way, I can just say, let me grab the supply chain details and I have to retype all that stuff I typed before, right? So here it is. And we're going to say, we're going to now say, okay, the task prompt is going to be the recommended solution. We're going to call this output the reallocation. And this is actually going to be an ontology edit that's going to be proposed by the LLM that we're going to have as our output. And we're going to have to give it two additional tools to get this part of the task done, right? The first is we're going to say we need to give it one more query tool because we need it to be able to query certain objects. And then we're going to have to give it an apply actions tool. So this is allowing the LLM to apply and stage actions, which I can then approve. So we'll do both those things here in just a sec. So for apply action types, I want to essentially say there's a create reallocation proposal action that the LLM should take given all of the information so far. And so I'm going to kind of go and find this particular action here and then include it in this particular create reallocation proposal. Here it is. And then I'm going to apply I'm going to add a different tool as well here, which is in this case, the query objects tool. And we're going to give it access to two additional objects, actually some of the same objects we did before, which is the Titan distribution center. There we go. There we go. And then also the finished good. And so just to summarize what we're doing here, right? We're saying we got those, details about what the affected customer orders were in the prior step. Now it's saying, let's check the recommended action. And then based on that, based on kind of the narrative output of the LLM, use the appropriate ontology-based action for that recommendation and stage a scenario or a set of approved potential edits for me. So what we're basically doing here is saying, great, it could conjure up an action plan. It could conjure up a set of actions. But I want to make sure whatever it recommends is anchored in my reality, my enterprise, which means specifically the actions that I have defined in our ontology. And so I'll save this, kind of give this a once over, okay, and then we'll run this and see what the final output is. And you can kind of get the idea of how logic works here based on, this example we've just sort of built up together, right? Which is, being able to kind of jump through here and, find specific outputs based off of specific tools and then chain those different operations together to kind of go further and further. So here we're seeing it kind of progress, get to that syringe step again, where it's identifying the tool, find, in this case, the customer orders. And you'll see, by the way, if I scroll up here, not to skip past it, there's sometimes failures, right? These things are imperfect, these LLMs. And so when they fail, you want to understand why. You want to be able to set retry logic or correction logic and be able to then tune prompts over time. It'll also show you sort of why it failed, right? Was it trying to make up tools that didn't exist? Did it not grok my instructions? Sometimes if my instructions are too long, it kind of loses track of the earlier instructions later on. So all these things are kind of considerations to think about, and logic helps me tune all of these things collectively as I develop. And so here, finally, we'll see, okay, it did kind of go through this final step here, and we'll say, okay, it actually did fail to run this scenario. And we'll see actually the reason for this is actually somewhat expected. It cannot load these objects and actually perform these edits. So I've given the LLM access to do everything up to the point of actually performing the action itself. And so because I've said it has to go through me, it can stage these actions, but it cannot actually go and commit them and kind of change our ontology automatically. And so kind of wanted to show that demonstration there at the end to just underscore the fact that it's always in your control, right? So even as you get up to this point, you can set these guardrails to ensure nothing gets committed automatically. I do have another file I set up earlier where it does succeed because I gave it different permissions. So if you want to see the happy ending, we can of course see it here. It'll run and it'll give it access to be able to kind of make these edits. The point is that once I bundle up this entire logic flow, right, which is quite intricate now, effectively is a pretty valuable routine, I want to be able to then put it on essentially an automated schedule or some sort of trigger-based schedule, where if I go back all the way to where we started, right, in those different user-facing views, and I go back to being somebody in a supply chain, somebody who's an analyst who does not care about like modeling all that intricacy, I can just come to the new AIP proposals tab that perhaps we have that's surfacing all of these recommendations being output by AIP logic, right? And I can even sort of see the kind of Kanban board, as it were, of where those things are in their proposal, approved, and modified process, right? So each of those different plans that were coming out of logic are actually rolled up for me as sort of objects and proposals I can review here. And so the point is it kind of comes full circle, right? Where an end user can make use of all that complexity. A data engineer can help build pipelines using AI. The application builder can help, accelerate their application building using AIP. There's a home for everybody in the platform. And I think what would be really excited to kind of further show you guys in coming weeks is, again, how all of this will keep evolving very rapidly across kind of every part of this diagram you see, every kind of thing itemized on the left-hand side, and then probably a lot more that isn't captured here too. So I know we've got about 9 minutes left and I've kind of whipped through this. So I want to make sure we do get to some questions.
Thank you so much, Akshay. Maybe take a breather. I'll batch up some of these questions for you. So I know you hit on this kind of immediately towards the end, but we've got a number of questions about sort of success, reproducibility, evaluations. Maybe I'll gather up some of those as an example. So, can we get to 100% success rate and then make it reproducible? Another version of this question is, the recommendation isn't 100% certainly going to be identical despite having the same inputs, prompts, references. How do you ensure sort of deterministic behavior? Is there sort of an introspection mode? Does the LLM self-evaluate the confidence of the return solution? As kind of another slice. So maybe if you could double click into that piece a little bit.
Yeah, it's a really important, I'd say, sphere of consideration, right? All those questions. And I think, the one thing that we think about is like LLMs are a very powerful kind of new technology, right? And I think kind of all transformer-based and derivative architectures will be, I think, is kind of our position, our assertion going forwards. And I think kind of fundamental to them is that they are not deterministic, right? They are essentially, what is an output of every token from a transformer is a logit, right? It's a statistical distribution that it then pulls from as it generates the token. And so you can get to a point where it's quite reliable, you're sort of correct on average for workflows, and even I think some recent papers have shown you can get up to 99% accuracy for 3-digit subtraction in addition if you really kind of tighten the prompting correctly. I think how we think about it is, where does the statistical magic or the statistical prowess really of these tools shine when interfaced with the calculus of the enterprise? So we think about it as sort of this mediation, right? This sort of yin yang between statistics and calculus. And I think what you're seeing with the tools and the binding that we're doing all the time in the different application states is this sort of theory, this philosophy we have that you want to be able to essentially introspect to the degree possible to what the LLM is doing, certainly to the latter question, and where it's really important to do that. Kind of a core tenet of AIP is you're never confined to just black box commercial LLMs. You can always use your own open source and tuned LLMs as well. And so we think there'll be like a lot of models used in lots of different contexts. So there's that aspect to it. The other is like applications like logic, showing you wherever possible the full chain of thought of how these models are actually performing. And there's going to be a lot of development in comparative chain of thought as well. So a lot of how we're thinking about LLM ops is, well, how can I see how Claude versus GPT is performing under different circumstances in Asia versus US distribution centers, like that level of granularity into the introspection. And then being very clear about what you're allowing it to do, even if you do have 90, 95, 99% confidence. You might still say, in certain operational settings, I do not want these LLMs to work, or I want them to hand off to these tools all the time. We think about this in statistical talk as mediating statistics through a calculating oracle, right? And like that could be a human, that could be an actual calculating piece of code, whatever it is. And I think making all of those options not just available, but clear, and building in kind of that opinion to the platform is a huge plank of the work.
Awesome. We have a few sort of various technical questions, so maybe I'll give those to you together. One is sort of on data types. So, can this work on voice, images, video? How does that interactivity work? And then another kind of interesting question here is, in the output pipelines, how do you ensure consistency with the existing ontology? So any conflicts with existing schemas, how do we think about that?
Yeah, I think on the first, absolutely. So multimodal usage here is really important. I think what's really interesting is, again, it's another area where I think our work with U.S. defense and our allied partners is really pushing us, I think, in ways that are having interesting echoes in the commercial space, where it's very important to be able to use, acoustic data, LiDAR data. It's some data is transcribed or can be sort of notionally represented or semi-represented linguistically. And it's like having pipelines that are mixing those modes, and having different transformer-based architectures, again, that are not just LLMs, but are the analogs in those other domains, is going to be really important too. I think you're seeing a bit of a heterogeneous spread of where in the progression curve those different types of models are, but you're definitely seeing a lot of really exciting stuff with acoustics, which is cool. So we'll definitely make those available. And like, this is all intended to be, it is designed to be intended for those use cases that are beyond just language. Absolutely. And to the point around, like, when we showed the pipelines and how, you have to sort of ensure structure, right? And make sure you're not kind of needlessly propagating changes from LLM augmented activity into your ontology. It's a super important point. And I think this is what we think of as kind of the table stakes for how you have to think about an ontology, where you have to have the proper guardrails and data versioning and change management in that layer, to be able to ensure that you cannot have things that are mismatched schemas, or even have not gone through the proper change management and human checkpoints that you've set up, propagate into the ontology. And so there's all these sorts of integrated checks you can configure to make sure that, like, if something does propagate forward from human or AI that is a mismatch, it cannot actually sort of succeed as a new build of the data. And there's transactional versioning to be able to roll back. There's abilities to have fallback branches as well, so you can test changes on a branch version of the ontology before you go to the mainline version. Again, a lot of what we have been building in ontological systems for years, I think, is really ripe for this sort of moment in AI, because exactly those sorts of plumbing considerations are instrumental to being able to use this stuff operationally.
Totally. Okay, I'm seeing kind of a whole host of questions on the general theme of getting started. So some examples are sort of, what does my internal talent need to look like in order for me to start? If there's physical equipment involved, are there any operational requirements? You showed a little bit of how this accelerates ontology development, but do I actually need to have that already in order to start? And then sort of a few on getting started timeline.
Absolutely. Great questions, right? And I think what we always do a kind of a mixed job of this in these demos, but like we kind of show the wide, big version, and things actually start in a very nimble fashion. And I think typically with a single problem selected, right? So we often think, like, what is the outcome that's powered by a starting ontology? The ontology will always be changing, and it can start with 2 or 3 objects that power an alert inbox, or a solution inbox, or an asset reliability 360, or something that's quite scoped to a particular outcome. And I think about the setup there as essentially being like a tiger team, right? It's somebody who understands the data. Maybe they kind of wear multiple hats in the organization, the data, maybe like in the systems, but also like how it's being used. There's some sort of business or operational user that has the workflow in mind. And then, there's maybe, somebody else from the business or from the analytics team. And it doesn't take more than 2 or 3 folks to get started. And I think, one of the things that I didn't really show here is, part of that is also to kind of increasing the scope of access here is having embedded AI assistants everywhere here. So I might say, how do I, create outputs for my ontology in Pipeline Builder? And this is kind of a cheeky example, right? But there's sort of AI assistants and tutorials here in the platform too, and it's designed to be very much kind of like a train the trainer model, where the Palantir team can help bootstrap, but then there's just a ton of resources now to be able to scale from a single use case at the pace you want to scale. And I think timeline is typically like, my metric is if we're not seeing some value in 6 to 7 weeks, inclusive of data setup, inclusive of networking setup, with just setting up the SaaS instance or whatever, we're probably doing something wrong. So it should be pretty quick to kick the tires on it.
Okay, maybe we can squeeze one more in here because this is a fun one to close out on. So we've got a question about any use cases or customer examples where we're integrating all of this with customer-facing applications that are sort of focused on operation optimization.
Absolutely. That's a really great question. It gives me an excuse to nerd out some more. I think it's this is like, so the latest kind of piece of this whole equation that we didn't really get to talk about in depth is what we call as the ontology SDK, or the OSDK, which is now gonna wrap everything inclusive of all the AIP features you've seen. So essentially think of everything you've seen in all the different tab switching I did, inclusive of this architecture I showed you before, as being a service mesh that is there for you to use and weave into your core enterprise assets, your ERPs, your existing hyperscaler stacks, your React applications, your data science environments. Like, it's designed to be a first-class citizen at every layer of that stack. And I think what's going to be really cool is all of the kind of things you saw here being accessible in a kind of headless fashion. If you want to build the next great application using those existing environments you have, or just mixed environments, but relying on kind of the iceberg of all the considerations here that are taken care of for you, from security to model binding to orchestration to pipeline building to ontology shape, like all of that essentially being something you can import and make use of in your custom builds. I think we're seeing a massive uptick in interest in using this essentially as the new backend for the AI stack. People said, oh, I did the data stack thing, that was interesting, but I need an AI stack now.
All right at time. Thank you so much, Akshay. Thank you so much, everybody, for joining us. I know we didn't get to nearly every question, so please get in touch with us. We'll reach out to you all. We're going to have another session next week. Please feel free to join again. It's going to continue evolving. Feel free to share with your colleagues, and looking forward to continuing the conversations.
Thanks, everybody.
Bye, everybody.